Hi friends, today in this session we are going to discuss about the topic data independence. We have already gone through many topics in database management system. Now we are going through the data independence topic in DBMS. If you hadn't visited my playlist in DBMS, please go through it, and if you like the video, don't forget to like, share and subscribe to my channel. And today in this session we are going to discuss about the term data independence. Now, first we start with this term data independence. What is this independence means? Independence means without depending on the another. What is without depending on another? For which we are not depending on another is on data. One data which won't depend on the another data is the data independence. Now let's see clarity what is the definition and what are the terms, why this term is introduced in DBMS. Okay, first we'll go through definition of the data independence. It is defined as the ability to modify data at one level without affecting the next level. So the data is changed or modified at one level. That is, we have already seen some levels in the database. They are like physical level, internal level, view level, that is external level. These are modified, these data at each level are modified. But if we modify the data at one level, it won't affect the data on the next level. Okay, it helps the users by improving the quality of data, as the it won't affect one level at if we modify data at the another level, it helps us, that is it helps the end users to improve their quality of data. That is, there will be more consistency in our data and effectiveness in our data, and by this there is no need to modify data structure in application program. What is this application program? I have already told this about this application program in our first video in DBMS, that is in introduction of DBMS. Application program is nothing but a program that we write in some programming languages, and they are written on the basis of using some data structures. And if we actually, before introducing this relational concepts and everything in the DBMS, this data structure is stored in the form of the application programs, and if we want to change any kind of data, we have to change the structure as well in the application program. But when these relational concepts and everything, relational model, all these have introduced, these burden has been reduced. So there is no need to modify the data structure in the application program, because it has a concepts of data independence. So there are two types of data independence basically, that is logical data independence and physical data independence. These are the levels actually we have all gone through with in our previous sessions, that is external. In the levels of abstraction, we have gone through all of these levels. This is external level, which is view level. This is logical or conceptual level. This is physical or internal level, and here our databases are stored. The logical data independence occurs between the logical level and external level, and the physical data independence occurs between the physical and logical levels. So, how is it possible? Now, let's see one by one what is this logical and physical data independence. Okay, logical data independence. It is a term that changes the schema at the conceptual level without having to modify the external level or application program. That is, it is a schema, it is a data that conceptual that changes at the conceptual level, that is at the logical level, without having to modify the external level or application level. As here we can see, logical level is connected to both physical level as well as the external level. It we change suppose we want to change data at the logical level. It logical data independence says that if we want to change data in the logical level, it won't affect the external level as well as the physical level. So simply it won't disturb the same data in the external as well as in the physical level. This is called our logical data independence. The external or user view would not be affected when there is a change in the conceptual view data. So the external, that is our external level, which is also called as view level, is not affected or is not disturbed data. Then next we have um, modification at this level. Modification at this level is necessary when there is any modification in the data structure of the logical database. So if we perform any modification, that is any change in our data structure, that is in our application program data structure, then we should compulsorily change the logical database. If it, as we have already discussed, there is no need to modify the data structure in the application program. But if in case we change the data structure, then we should compulsorily change the logical database. Okay. Next, following are some examples of logical data independence which will not affect the external or user view. Let's see what are this. We can break existing record into more than two records. That is, suppose we have a data of student name, student roll number, student age, student course. Then we can divide this data into two sub tables, that is two sub relations. These are nothing but dividing into two sub records, like name, roll number, age, and name, roll number, and course. We divide on the basis of these three columns and these three columns. Okay, so we can break existing record into more than two records, which will not affect the external or user view. Mostly in logical data independence, we mostly go through with we mostly observe that logical level won't affect the external level. Okay, if we change any data in the logical level, it won't affect the external level. Therefore we observe this logical independence in between these two levels. Okay, so here, next, the second point is we can also combine two records into one record. That is, these approach can be top to down or bottom to up. Okay, we can easily modify, delete, or insert the attributes. What are these attributes? Attributes are nothing but columns. We can insert any sort of columns here. I can also insert some department column or some what that fees column. Everything we can also insert or modify. This won't affect the user or external view. So next we are going to see about the physical data independence. So next we have physical data independence. This is another type of data independence that alters the schema at the internal or physical level without having to alter the schema at the conceptual level. That is, if we make changes in the physical level, that is, we make changes in the physical level. That is a step which is related to the stored database. It won't affect the data in the logical level. So if you change in the physical level like in the data structure, then there is no effect in the logical level. Let's see how it's possible. Here, the conceptual structure of the database system will not be affected if there is any modification in the storage size of the database. So uh, physically, actually, we store our data in the form of a storage size, that is in the database. That is, a size may vary, and these are size predictions which won't affect the logical structure, that is our logical level. So these physical data independence will occur between the physical or internal level and the logical or conceptual level. So these type of data independence can be achieved easily. So it is easy to achieve this kind of data independence as compared to the logical data independence. So following are some examples of physical data independence that will not affect the conceptual way. What are these? Will not affect, that is will won't give any impact on that level if we perform this kind of examples. What are that examples? Let's see, we can modify the indexes in the database system. So we can change the index values in the database system. Index values in the sense, if you have already gone through data structures concepts, we in the linked we have a linked list and the stack as well as queues in these data structures. These linked lists are stored in the form with the help of the indexes. These index, every node has an index value which is connected to the another index value. If we change these indexes in the physical level, then it won't affect the logical level. Okay, this is the point we are going through. Next, we can easily modify the data structure which is used for storage. So if we make any changes in this data structure, if we make any modifications, if we make any changes, then it won't affect the logical data, that is sorry, logical level. Okay, this is all about the data independence. So if you hadn't gone through the DBMS playlist, please go through it. And if you like the video, don't forget to like, share and subscribe to my channel. It gets motivated to me to do more videos on this subject. And if you want any other topics, please suggest me in the comment section. And thank you.